We can also deploy our double angle formulas to help us solve equations. So in the example that we see here, we've got cosine of 2x plus the sine of x equals 0. And so the issue that we have here is, first of all, we have a mix of cosines and sines, which is going to make solving the equation impossible. But on top of that, we've got one that has the double angle 2x in it, the other one has the single angle. So we're going to have to deploy our double angle formula for cosine of 2x. Now in the case of cosine of 2x, remember we have 3 different variations of that identity that we can make use of. But I'm going to use the one that involves only the sine of x, because then that'll be compatible with what I have in my equation here to go along with the cosine 2x, which is just sine of x. So I'm going to substitute 1 minus 2 sine squared x plus sine of x equals 0. So I'm going to make that substitution. I'm going to replace cosine of 2x with 1 minus 2 sine squared of x, so that now my equation is only involving the sine of x. So I'll be able to factor here and solve. Now I'm going to rearrange the deck chairs on this Titanic, and I'm going to multiply everything by -1, because since I'm going to have to factor, I'd really prefer to have that squared piece positive. So I'm going to write that first. So I've got 2 sine squared x, and then since I'm multiplying everything by -1, I'm going to have a minus sine of x, and then a -1 equals 0. And so I'm going to factor this. Again, I think I've shown this in previous videos. If we think of this as 2x squared minus x minus 1, and I want to break that up into a couple of sets of parentheses, that's really what I'm working with here on this example. And so if we were to continue factoring this as just x's rather than sine of x's, we can see we're going to have a 2x and an x as the first piece in each set of parentheses. So that means I'm going to need to have 2 sine of x and sine of x as the lead piece in each of my sets of parentheses. I'm going to need a positive and a negative. I need the negatives to win out. So if we were to factor this, I'm likely going to put the negative away from the 2x and the positive away from the x. And then we multiply to make 1 by just 1 and 1. And we can see that would be the factorization of that algebraic equation when it's just x's. So I'm going to do the same thing here. So we're going to have 2 sine of x plus 1, and then sine of x minus 1. And if we double check and refoil that, that'll get us back to our original equation. And so now I need to take each of these factors and set them equal to 0. So I've got 2 times the sine of x plus 1 equals 0, and the sine of x minus 1 equals 0. And so if we isolate sine of x in each of these equations, on the left side here we're going to get sine of x equals -1/2. And the other one we're going to get sine of x equals 1. And so now we're at the point where we've got to use our arc sine. So if we take the arc sine of both sides of each of these equations, we're going to get x equals the arc sine of -1/2. And in the other one we get, x equals the arc sine of 1. So then we go to our definition of arc sine. So I'm just going to scroll down here a little bit, give ourselves a touch more room. So the definition of arc sine says we've got x equals the inverse sine of -1/2 plus 2 pi n, and we've also got pi minus the inverse sine of -1/2 plus 2 pi n. And so for this one over here, we'll slide over. We've got x equals the inverse sine of 1 plus 2 pi n, and pi minus the inverse sine of 1 plus 2 pi n. So let's go back over here to the left. The inverse sine of -1/2. Again, remembering our rules for that one answer that we get for inverse sine. So we're going to get an answer that's in the 4th quadrant, but it's got to be a negative value. So the inverse sine of -1/2 is going to be -pi/6 plus 2 pi n. And then we've got pi minus that negative pi over 6. So pi minus a negative means it's going to be plus. So pi plus pi over 6 means we're going to get 7 pi over 6 plus 2 pi n. And then for the other part of the equation, if we move over here to the right, the inverse sine of 1, my answer for that is going to be pi over 2. Since we've got to be between negative pi over 2 and positive pi over 2, so the y-coordinate on the unit circle is 1 at pi over 2. So I've got pi over 2 plus 2 pi n. And then, as it turns out, pi minus pi over 2 is pi over 2. So we really only end up with one equation out of the second part of the problem. But we've got these two equations here. And so taken together, that is our infinite solution set to this equation. Now we generally, for all these problems, have also looked to get our answers that are between 0 and 2 pi, that are in that interval. And so if we plug in 0 for n everywhere, if we start to build that list, we can see we get a negative answer out of this first equation over here, so we're going to leave that off. We get 7 pi over 6 from the second one. We get pi over 2 from this one over here. Now if we plug in 1 for n everywhere, well, the two that started with a positive value are going to be too big for this interval, but that negative pi over 6 over here plus 2 pi n, so 2 times pi times 1, so negative pi over 6 plus 2 pi gives us 11 pi over 6. And so there we've got our answers that are in that 0 to 2 pi interval that we're always looking for.